This is Gail Kovac with Gresham Barlow School District, Summer School, High School Credit Recovery, Geometry, and Learning Target number 5. I can find missing angle measures using the triangle sum theorem. So there's a famous theorem in geometry, the triangle sum theorem, that any triangle in the world, its 3 interior angles will always sum to 180 rotational degrees. That is because the 3 angles of any triangle can be moved around and put together to form a straight line, and a straight line is defined to have 180 rotational parts called degrees. And there's a whole proof to that, but what we'd like to do is use that theorem to find some missing measurements. So on this problem on the left, we have just a basic triangle. I am given 2 of the angle measures, and I need to find that third missing piece, and that third missing piece must be the quantity such that those 3 angle measures are going to sum to 180 degrees. So I'm going to put my 65 degrees and my 57 degrees together, and adding that with my unknown right here, my unknown, that must add up to 180. So now I'm going to solve for that missing value. So let's see what 65 and 57 add up to so far. That adds up to a total of 122 degrees. So far we've got 122 out of the 180 covered. What does that third measurement have to be to give you a total of 180? So what you could do, if you're doing a little bit of algebra, you could subtract 122 from either side to isolate that unknown. And then that's going to give you what you're missing here, that question mark is going to be whatever 180 minus 122 is, and that's going to be 58. So that third angle measure must be 58 degrees. Now you can double check if you're correct using a calculator. Make sure that 65 plus 57 plus the unknown 58 has to add up to 180. If it does, then you've got it. Now let's look at the next problem. This next problem uses the triangle sum theorem, but it's not the only calculation you're going to need to figure out your missing value, which is in fact over here this time. So we need the triangle sum theorem. There is a triangle hidden in this figure right here, triangle right here. So this has to add up to 180 degrees, and I am going to draw that in red. So this has to sum to 180 degrees. Now, we don't have, unfortunately, 2 out of the 3 of the measurements to get to a full triangle here. We've only been given 1, so I don't know what either of the other ones are. And in fact, the value that I'm looking for is not even inside the triangle. It's outside. It's outside there instead. So we're going to treat this a little bit like a puzzle. We're going to see what missing angles we can figure out in this figure so far, and then we're going to slowly make our way around to that question mark value. So we know that a triangle, the interior angles of any triangle sum to 180 degrees. That's because it makes a straight line. So a straight line will also make 180 degrees. Like these 2 angles here, the 155 and whatever this is, this also has to add up to 180 degrees because that's a straight line. That's by definition. So I can figure out at least what this angle is. I know that's not the one I'm looking for, but maybe it'll lead me to the one that I'm looking for. So I'm going to take that 180 and I'm going to subtract 155 to figure out what I'm left with. And I believe that's 25. I'm going to verify just to make sure. That is, let me see, 180 minus 155. That is, in fact, yes, 25 degrees. So that's what we are missing over here. So these 2 angles, this linear pair, must sum to 180. That means that this one has to be 25. Okay, let's see what that information has bought us now. Oh, now I do have 2 out of 3 of the measurements of this triangle here. I've got 25 and 60. I've only got this missing piece right here to get to 180 degrees. So let's see what they add up to so far. I've got 60 and 25, 60 and 25. That adds up to 85. So let's see here. 85 is what we've got so far. Let me subtract 85 to 180 to figure out what this remainder piece has to be, and that's going to be this angle right here. So 180 subtract 85. I think that's going to be 95, because if this were just 80, that would be 100 left over, but we're taking 5 more away. So yes, 95 is going to be what remains. So this angle right in here must be 95 degrees. So I'm going to put 95 degrees. All right, well, we're figuring some things out. I wonder if that helps us get to my missing angle. We are getting closer and closer, inching our way through this shape here. And in fact, yes, here's something else I know. These two angles right here, they make up another linear pair. They make up a straight line. So by definition, those two angles also have to add up to 180 degrees. So I can now take 95 away from 180 to figure out what that question mark has to be. All right, so 180, take away the 95, I believe, is that going to be 85? I think so. 85 degrees. I'm going to verify. Yeah, I just did that math over here. So yeah, that's got to be 85 degrees. So my question mark, that value I was looking for there, it's got to be 85 degrees. That's the only value that'll let this linear pair right here add up to 180 in green. It's the only value that will have this triangle with this third missing angle add up to 180. It is the only value, whoops, that's supposed to be red, sorry. That is the only value that'll let that linear pair in blue also add up to 180 degrees. They all kind of affect each other with all these linear pairs and interior triangles. So just remember, 3 angles of any triangle, the interior angles must sum to 180 degrees. And a linear pair, any 2 angles that are next to each other, also add up to 180. So you can either find it directly, like in our first example, just go straight for the triangle right here, or you can kind of inch your way through a figure using those 2 to find those missing values.